of there are two types of polymerization: addition polymerization and condensation polymerization. Now, this is actually condensation polymers are formed when two different monomers are linked together with the removal of a small molecule, usually water. This is different from the previous polymerization, which was called addition polymerization. So there are two types of polymerization. One is called addition polymerization, and the second is called condensation polymerization. Now, we had started in our previous class, and I had explained you that even though polymerization is not coming in the mock, but I have already done enough organic, and I'm planning to finish it. But the syllabus for mock says they are giving the organic till alkenes. Okay. So, but anyways, we have done, it's only a little amount of work is left, so we should complete it. Condensation polymers are formed when two different monomers are linked together by the removal of a small molecule, usually water. What's the meaning of the word condensation? Condensation means removal of water. Condensation means removal of water. Now we have to see this concept. Look, this one, red color, then blue color, then red color, then blue color. These are monomers. In condensation polymerization, the monomers are not necessarily the same. Different monomers can be joined. Different monomers can be joined in this way. Different monomers can be joined in this way. Now look at this concept. Condensation polymers examples: polyamides, polyamides, and polyesters. Do you remember these names, polyamides and polyesters?
Yep.
Polyamides and polyesters. Now, we had started polyesters. Let us recall again alcohol, carboxylic acid, and ester. Can you identify them?
Yeah.
Condensation reactions occur between diols and dicarboxylic acid to form polyesters. The word di means two. Now, do you remember this theme? Two carboxylic group, two alcohol group. This is the first one called dicarboxylic and second is called diol. And these shaded rectangles are hydrocarbon units. Can you recall it? We did on that day.
Yeah, we did.
You recall it?
Yeah.
Okay. Now look at this. The shaded rectangles are showing, the shaded rectangle are showing the hidden hydrocarbon. The hidden hydrocarbon is basically connecting the two carboxylic group. Now look at this. Now I'm starting the polymerization. This is an example. Left side is a dicarboxylic acid. Right side is a diol. Now you have to copy this.
I think I already copied this.
No, not you have to copy in this orientation because I have to start polymerization. So you have to copy in this pattern side by side, so we can discuss the polymerization, which is called condensation.
Done. I copied this also. H2O water molecule is removed.
Yes. Now, can you explain that how water is removed in this example from where water is coming up?
There's two H's and one O. So H2O.
One molecule is losing what? One molecule is losing OH, other molecule is losing H. They together are forming what? They together are forming what?
H2O.
They together are forming water. So now make a concept, Mikhail, that what is condensation polymer? How water comes out? One molecule releases OH, one molecule releases H. H and OH combine to form water. Now what we do? After removal of water, you stretch the molecule, pull them in and connect them. This is called condensation polymerization molecule. Just like you make a break, you take out OH, you take out H, merge to get water. Remaining two molecules are pulled towards each other, and they make the final molecule. Look, this is called the ester link. Now you have to copy this also.
Yeah, copy this.
Now, I have made a block. This COO part is called ester link. This is called condensation polymerization. And this box is called ester link.
What is the ester link?
COO. COO and both side hydrocarbon RCOOR. This is called ester link. One carbon, because one carbon, double oxygen, and both side hydrocarbon is called ester link. Look, this in the box. This box is called ester link.
Ester is COO, right?
No, I told you last time, remember, what are esters? Esters are
COO is the formula.
Look at this. This is ester.
Yeah, okay.
These are esters. Now we move forward.
So why do we need an ester to be formed?
This is the way. This is called esterification. The final product is an ester. I had explained last time what are esters or polyesters. Polyesters are actually artificial fiber. We use them for making cloth, making artificial fiber, making dresses. As compared to cotton, they are very economical, even though not that much comfortable, but they are very economical because they are man-made. What these boxes represent? These boxes represent hydrocarbons, which can be shown directly also. Now look at this example. This is a structure of a polyester, okay? In the exam, he will ask you to identify the link. So I'm sharing this link. This is, look, this is an ester link. This is called ester link. Ester link is COO link. Now, if you break the molecule, you can get the monomers back. There are two types of question. One, using the monomers, make the polymer. Second, polymer is given, break it and get the monomers. breaking the polymer means you have to reverse the process. This is called a polyester. These boxes, basically, these boxes are showing hydrocarbon. I will show you again. Look, this is, Mikhail, this is the ester link. Look, this is the ester link. That can be converted back into monomers and repolymerized. I mean, you can convert it, you can break it down, get the monomers again, and different plastics are made, like bottles, the water bottles in our homes, which we put in the fridge, in the refrigerator. These are PET. PET means it's basically a polyester. This polyester is used in making artificial fiber, synthetic fiber also. Again, the problem, how we manage it, we actually make a recycle process so that this plastic doesn't become a part of pollution. Now, we are putting an example, ethane dioic acid and ethane diode. No, look at these names. People always get very much confused by these names. This is a diol, and look at this, let me underline, it is actually a dioic acid. What is a dioic acid? It means two carboxylic group. Look, one group here, one group here, two carboxylic acid. Look, one OH here, one OH here. This is called diol. Diol means double alcohol. Now, look at the structure. I will show you the identification. Look, this is a carboxylic acid. This is a carboxylic acid. This is an alcohol. This is an alcohol. How we connect them? We remove O, we remove H, we remove H. They all together form water. Remaining molecules, we connect them, and water is the byproduct. This is called condensation polymerization. They have a lot of application. I have already explained: artificial fiber, bottles, regular plastic, etc. Now, give the heading hydrolysis.
Do I not write anything from the last slide?
No, no need for that. We will obviously use, we will always use the notes. Did you see the notes I had sent to you on acid and bases from Save My Exam?
Yeah, I think I did.
You should look at them. You should look at them because they are very good notes. And if you can make a pattern of learning, because 1 month, within 1 month, actually now, within month one, you are going to have a very big exam. So if you like those notes, I can provide you. You can also download yourself, make a folder of and copy down every note, every document, every chapter. The pattern notes are necessary because obviously you have to learn the conditions, the equations, the apparatus. They all are important. One query is still pending, that is paper 6. So you have to ask your school, are they going to give anything from paper 6 or not?
Okay.
So whenever you go to school, if you have a school next time, whenever you go, remember to confirm, because sometimes school teachers announce in a very late position that, okay, fine, now paper 6 is also coming. That will be a big problem for you. You have the past paper, but you don't have enough time. You have to cover other subjects also. So the plan is very simple. Take one chapter, see our notes, class notes, see the detailed notes, and start doing the questions. Keep a record on your book, put marking on the book, 4 questions, 5 questions, good. Keep on doing them, and in that way, if it's a 1 month time, you can make a timetable for you that in 1 month there are, suppose, 10 chapters coming. So you have to just like finish in 1 chapter in 2 days. This you can apply for every subject. In that way, you will not be in a problem, because the time factor becomes a big problem in the final year mock 1, because a lot of syllabus comes. Now, what is hydrolysis? Hydrolysis is the introduction of OH. There are 3 types of hydrolysis: water, by alkali, by acid. Hydrolysis is defined as reaction with water, introduction of OH group. I repeat my concept. What is hydrolysis? Hydrolysis is the reaction of a substance with water It is the introduction of OH group for organic compounds. Can you repeat what is hydrolysis?
Can
What
you
is
repeat?
hydrolysis? I repeat once more. Hydrolysis is the reaction of a substance with water.
Okay.
What is hydrolysis?
Reaction of a substance with water.
Yes, hydrolysis is the reaction of a substance with water. So I put the definition here. Hydrolysis is the reaction of a substance with water. I put my second concept here, which is related to hydrolysis, I'm putting my second concept. It is the introduction. It is the introduction of OH group in an look at the definition, the second concept, Mikael. What is the meaning of this second concept? It means what is hydrolysis? Hydrolysis is the introduction. Hydrolysis is the introduction of OH group. Now, let me show you the example. CH3, CH2, and here it is, Br. CH3, CH2, Br, and I'm sending an OH group. I'm sending an OH group from outside. This is a hydroxyl ion. Now, you have to see what happens. The bromine, which is a halogen, is replaced by the bromine has been attacked by the OH, and OH comes here and sit in place of bromine. This is like a substitution reaction. Bromine has been kicked out.
Just because something about reactivity, right?
You can say that, but here in organic, Nikai, the conditions are important, like heating, like putting a catalyst. So this is not only the activity, we make conditions such a way that the reaction go in this particular direction. This is bromoethane, and this is, there are two carbons with an OH. With an OH means it is an alcohol. So what would be the name of CH3, CH2OH?
Ethanoic acid.
Yes, it is ethanoic acid. Think again, or very close, it is ethanol.
Ethanol.
Why it is not ethanoic acid?
Is that carboxylic acid?
Yes, ethanoic acid would be a carboxylic acid, which is not a case here. Acha, bromoethane is called a Geno alkane and alcohol. So this is called hydrolysis. Can you define back for me what is
But
hydrolysis?
where is the water here?
Where is no? That's a very good question. Water is only a reference. Water is used only a word reference. That's why I have given you the second definition also. Water is only there as a donor of OH. Water is not shown here. Actual introduction is OH. Water is a medium to provide OH minus.
But if it's water, shouldn't it be H2O? Hello?
Yes, I'm listening.
Yes, that if it's water, shouldn't it be the introduction of H2O, not
No,
OH?
make a chemistry concept, Mikhail. Whole water cannot go in anything. A whole compound cannot go in any other compound. Compounds do not get into whole. They always break and go in pieces. Like you cannot put water just like we drink water. This is hydration. Water does not go as a whole. Water breaks and OH goes in. It is not the introduction of water. It is the introduction of OH minus. OH minus is coming from any source like water. Remember, water can break down into H plus and OH minus.
Let me write it down. Done.
Condensation polymerization can be reversed by hydrolysis. This is a very important concept now. If you want to break down something, you call it decomposition. If you want to break down a condensation polymer, you have to do hydrolysis. So what is hydrolysis? Hydrolysis is the reversal of hydrolysis can reverse the condensation polymerization. So you can reverse the condensation polymerization by hydrolysis. Why? You remove water, this is called condensation polymerization. If you get water back in the system, it is called hydrolysis. So what is the concept? Condensation polymerization can be reversed by hydrolysis. What are the options for hydrolysis? We can use pure water, we can use an alkaline medium, and we can also use an acidified medium. So hydrolysis can be done. Hydrolysis can be done by three possible routes: by water, by alkaline solution, and by acidified medium. So you have to now look at this. You have to memorize this point.
So condensation polymerization causes water to leave, and
Remove.
hydrolysis causes water to come back inside.
Yes. And it means it is a reversal. So hydrolysis reverses condensation polymerization. Now we introduce the concept of amines.
1 second.
So now give a new heading, amines. Give the heading amines.
Done.
Now, look at the formula, Mikhail. First of all, RNH2. NH2 is the amino group. This is the general formula. RNH2 is called amines. RNH2 is called amine.
Done.
This is called amine. Okay. Now, what is R? R is the alkyl radical. So R can be CH3, then it will become methylamine. R
What
can
is
be,
it?
please go ahead.
What is it? H3C? CH3, no?
You can write it CH3, but it's a convention to show the bond with carbon. I have to show the bonding with carbon, so I have written it in reverse. This is a convention to good convention to follow, but you can write it CH3 also. H3C actually means CH3, one carbon, so methylamine. This is basically RNH2. Acha, what is R and what is the meaning of this RNH2? RNH2 means alkyl amine. RNH2 means alkyl amine. And what R stands for?
Alkyl radical.
Yes. R stands for alkyl radical. So it can be CH3, it can be C2H5, it can be C3H7, any one of them.
C2H5 is ethanol.
2 carbon means ethyl, 3 carbon means propyl. Now let's make the family. CH3NH2, this is methylamine. C2H5NH2, this is ethylamine. So it goes on like this. So you have to copy this also for understanding.
So whatever comes for alkyl radical will be ethyl, propyl, pentyl, hexyl.
Yes, this is actually going like that. Now you have the book. So when you start doing some questions, which I'm emphasizing every time, then you will understand that these structures are the major game changer. Theory is not important. In organic theory, doesn't come much. All the game moves around these structures. Sometimes they go for displayed formula. Sometimes they go for molecular formula. Sometimes go for structural, empirical. Sometimes they show the full structure. These structures are actually the problem.
Done.
Give the heading amides.
Done.
Look at the structure, Mikhail. RCONH2. This is called amide. RCONH2. And I had already explained that organic actually is always this complication of these structures. I can write it in a bit condensed form, RCONH2. NH2.
Okay, done.
Now, give the heading polyamides.
Done.
Polyamides are a group of synthetic or natural polymers made up of repeating amide groups. We have studied right now, and obviously you would have understood that why we have introduced amides, because now we are going to discuss polyamide. Poly means many. Now, what are polyamides? Our protein structure, you must be liking some of the protein, like some people like fish, some people like red meat, some people like the white meat. They all are protein. Our skin, our body structure, all consist of protein. Protein is one of the best example of polyamide. Then in our homes, you can find nylon ropes, very strong, and people tie the boxes with it, and for packaging, for even pulling the vehicles. And this is called polyamides. So what are polyamides? Polyamides are a group of synthetic or natural polymers which are repeating groups, amide groups. Amide means RCONH2. So you have to copy down the definition after giving the heading.
Done.
These are called polyamide. Now identify this group, huh? NHCO group. This is called amide group.
Amide.
What is an amide group? As I said already, organic is actually a separate chemistry. It has its own language, some important groups to remember. Amide group, NHCO. NHCO group.
Isn't NH2?
Now this is a good concept. I have taken out one hydrogen. Now look, make a concept, Mikhail. You have when you need to connect something, you have to get one bond free. I give you an example. I give you an example. Suppose I want to connect ammonia, which is NH3. This is my ammonia. I want to connect it with OH. Okay, I cannot connect because NH3 is complete. OH is not complete, but NH3 is complete. So what I will do, I will take out one hydrogen. It will become NH2. One bond is now free. Then I will attach OH there.
Okay.
So why it is not NH2? You can see the open end. Let me make an arrow. This open hand. This is the open hand. Why there is an open hand? Because I have removed one hydrogen. I have removed one hydrogen from here, and I want to make a hydrogen link here. So this is why some molecules I have shown which are not in their full form. Polyamides from a dicarboxylic acid and a diamine. Now you have to copy this heading.
Carboxylic acid is CO2H, right?
Yes, very good. Carboxylic acid is CO2H. What is amine?
Mine is R
NH.
NH2. Yeah.
Yes. This is the organic chemistry language.
Okay, done.
Now, remember this concept that we are talking about a CONH group. Look, this is called dicarboxylic acid. This is called diamine. Then what is condensation? If
So
you
can you show
remember,
that diamine again?
but first you see this polyamides from a dicarboxylic acid and a diamine. What is polyester? You remove water by condensation, you get this. This is called amide link, which is also called peptide link. Did you take bio or maths?
Both.
Oh, then it's easy for you. I think you must have studied some of peptide linking in bio. If you have studied some part of protein, you might have studied it or you will study it. This is called CONH. CONH is called peptide link. As a joke, our chemistry people say that this is ourself. We are protein structures, and our protein structure actually survive on these links, peptide link. So now you have to copy this first.
Okay. Okay, done.
This is called amide link. Now identify dicarboxylic acid, 2-carboxylic group. Identify diamine, which is 2NH2 group. So you have to copy this also. I'm just coming in a minute. Copy this.
I'm done.
Now we are preparing for making the polymer. One side is my dicarboxylic acid. I have put it side by side. Why it is necessary? In the paper, there are two types of question. One, they give you monomers to join to get polymer, or they give you polymer to break into monomer. Now you have to copy this side by side.
Okay.
Have you copied it?
Almost done. Okay, done.
Now, now do the step, remove water.
Okay, done.
This is the first step. Now pull the molecules and join them.
Done.
Now this is called, look at this repeat unit. This is called polyamide. When you join it by CONH, look at this. Now this is the very important key concept, Mikhail. You have to identify this box in the exam. This is the repeat unit. This is called amide link. You have to copy this also on the same diagram.
So polyamines are formed by a dicarboxylic acid and a diamine.
Sorry?
Polyamides are formed from dicarboxylic acid and diamine.
Yes. Very good. This is to memorize.
So, but is it not going to be CONH2?
Hmm?
It's not going to be CONH2.
No, I have answered this already. If I make NH2, Mikhail, then how I connect it? NH2 means all bonds full. Nitrogen has 3 hands. So it cannot be NH2 because you need 1 hand free for the box to be connected. NH2 means 1 nitrogen and 2 hydrogen. That's not possible because I have to connect 1 hand to left side carbon, 1 hand to the right hand side box, and 1 hand with hydrogen.
Okay.
Okay. Now I tell you, I clear this concept. I want to clear this important concept and I ask you a little question. Let's see if you have understood. CH4 and Cl, how you connect them? Can you connect them?
CH.
If I write, Mikhail, if I write,
CH3HCl.
good. This is wrong. Why this is wrong?
Because there's no bonds to joins. Because CH4 has no spare bonds.
Yes, very good. Now you got the concept. This is the reason. If I write 2 here, now it becomes wrong. Nitrogen has only 1 hand remaining. Acha, now this appears in the exam. This is called a polyamide. How you identify it's a polyamide? This is called a polyamide. This is called an amide link. This one is called polyamide. Now give the heading amino acid.
Done.
Right. What are amino acids? Acha, can you tell me, because this Saturday timing was having a clash with other work, with my other work. So I got another option if you have. Uh, acha, what is the time at your place now? Is it 250? Oh, sorry, is it 150? 250.
Chemistry class?
No, no, no. Uh,
My before classes.
what is the time in your area right now?
Right now it's 2:16.
Acha. So matching now. So I was thinking if acha, what about Wednesday 7:30? But you told me I think you have a class on Wednesday. Acha, acha.
Wednesday I have academy.
Hmm. Acha. What about acha? That would be. What about Tuesday? Tuesday 7:30? No, sorry. Tuesday 8:30.
8:30 my time.
Yes, your time. It's not a hurry. You can think. You can check it. You can tell me later. No hurry.
Tuesday. No, I have another class.
Hmm?
I have another class on Tuesday.
Oh.
I can do it earlier, like 4 to 5 my time.
Four,
Or
5.
4:30 to 5:30.
But you have a school also, no?
No, I come back home at 3.
Mm-hmm. Okay. And Wednesday, Thursday, Thursday. Because this Saturday actually is clashing with my other college work. Acha, Monday you have Monday. Acha, 4 o'clock will be too early then. Monday, let's move forward.
Also, my Sunday classes will have problems now because a tournament
Having
started and mostly my matches will be in the morning. So tomorrow I have a match at 10, so I won't be at home. So Sunday classes will be problems from now. Because every Sunday now I'll have match Sunday morning.
every Sunday.
Yeah, it's for 16 weeks.
Oh, 16 or 6 weeks.
16 weeks.
Oh.
So Sunday mornings I can't have classes.
I was trying to fix one day and you have asked me for another day. Now the situation is even more critical. Okay. Anyways, let me see. This Sunday you have a, and you're saying this every
I'm free on Monday and Tuesday 4:30, 5:30, or Monday 5 to 6 or 5:30, 6:30. Monday and Tuesday. And I think Thursday also. Let me check.
this is a big challenge now. Monday I have in your time zone, Monday I have 4 to 5 available, 4 to 5.
4 to 5.
But it can be very close to your school actually.
No, it's fine. Do you have 4:30 to 5:30?
No, that's a problem. Na? It goes because now virtually we have to check our two classes actually. We have to check two of our classes because Saturday is clashing with my time and Sunday is clashing with your time. So we are virtually having a double clash. So let me work it out. You can check Monday 4 to 5 and I can tell you for tomorrow at least. But right now, let's keep it up to here. We can inshallah do for tomorrow. Let me find out the option and then we can work out again. Okay. So let's stop here and we will inshallah continue in our next class.
Okay.
Allah.